Hello, everyone. Welcome to 3D Natives webinar, How is AM Revolutionizing Industry in the Balkans? My name is Madeline Pryor. I will be the moderator today, and our panelists today are Giuseppe Cilia, Carlo Cavallini from Desktop Metal, Maria Papagiorgio, and Lefteris Chavousis from Lino SA. I apologize for my butchering of names. I am trying. From Lino SA, based in Greece. Good afternoon, everyone.
Hi, hello.
Hello.
It's great to have you here. So I will introduce myself and the panelists in a little bit. But before we get started, and while people are still trickling in, I just wanted to take the opportunity to send a survey to all of you to get some information about you and your expectations for the webinar. Here are the questions. Just give me 1 second. So you should be able to see it on your screen. Please do answer the questions. It's just, as I mentioned, to give a little bit of information about you and what you want for the webinar. That way we know what you expect and what you want to get out of it.
Right.
And so you can, it's on the screen, so please vote. I'll leave it up for a few moments to give you the opportunity just to go through. So while people are coming in and voting, I'll start talking generally. Just to let you all know, the webinar today is being recorded. It will be put on YouTube either tomorrow or in the next few days. It is on 3D Natives YouTube channel, and you will be able to see it and watch it again if you want, or send it to your friends. So it will be available if you are interested. If you'd like to be notified before, well, when it goes online, then you can subscribe. We, as our name suggests, have a lot of interesting 3D related content for you to look through. So I'm gonna still keep it up while people are voting. So also just to let you know quickly, I'll mention this a few times, but if you look at the bottom of your screen, there's a Q&A button. In this section, you can ask questions to the panelists. As you'll see in a moment, there's a Q&A section. So you'll be able to ask questions and we will answer them during the period. So please do use this dedicated area for the questions. That way they don't get lost, because sometimes there are a lot of messages. It will keep them in one place so we can answer. Okay, great. Well, I see most of you voted, so I'm going to end the poll. And let me share the results with you all. You should be able to see it on your screen. Unsurprisingly, most of you are currently working in the field of AM. You also mostly have a 3D printer. It seems most of you are also using FDM. Unsurprisingly, you're interested, 63% are interested in learning more about additive manufacturing in the Balkans. And most of you actually aren't from the Balkans, and you're not familiar with the topic. Well, you are in the right place in that case. We will go into that today. So let's get into it. So this is the agenda for the webinar. As you can see, it will be the first 10 minutes for the introduction, which is done by me, obviously. Before next, we will move into a closer look at additive manufacturing in the Balkans by Lano. Before Desktop Metal will show a little bit more about the currently used AM technologies in the region, as well as how they can be used to revolutionize traditional industries. Finally, we'll get into case studies. Specifically, there's a few case studies we have for manufacturing, marine, molding, all those kind of things. So you get a sense of how AM is already being used in the region. Finally, as I mentioned before, there will be a Q&A, and you can ask your questions in the Q&A section. So let's go to the next slide. So for those of you who don't know, there can be some disagreement about which countries are considered Balkan. The general consensus right now is that it is made up of Albania, Bosnia and Herzegovina, Bulgaria, Croatia, Kosovo, Montenegro, North Macedonia, Romania, Serbia, and Slovenia, as well as Greece and Turkey. This is what we refer to as the Balkans region, also sometimes as Southeast Europe. You'll hear both used interchangeably. Traditionally, industry in the Balkans has been centered around sectors like manufacturing and the maritime sector, unsurprisingly. Though, of course, that's not exhaustive. There are quite a lot of sectors in the area. Also, as you can see, over the past few years, the region has been gaining quite a lot of buzz as it has grown exponentially. Thank you. It has grown exponentially in terms of economic growth. The figure on the screen is actually from the World Bank, but in the OECD's report, though there's a few reports that talk about how important the region is becoming for especially manufacturing. In this chart, this is the growth in 2018, but I can tell you that apart from 2020, where every region showed a decline in economic growth, unsurprisingly, as a cause of the pandemic, in 2021 and 2022, it is forecast that the Balkans region will continue to grow significantly, notably showing a higher growth rate, as you can see here, than the rest of the European Union, making it a very important area for investment as well as manufacturing. And that's where we turn to additive manufacturing itself. Next slide, please. So, well, I think most of you are in AM, so you are aware, but additive manufacturing has been also growing significantly in recent years. It is one of the few industries which was affected, but not too much, by the pandemic last year. It was one of the few that continued to grow despite the economic crisis caused by COVID-19. And it is expected to continue to grow in coming years. There are a number of different AM technologies in a number of sectors, but it is expected to become especially important in the Balkans because of traditional manufacturing in the region, especially with metal, and it's expected to help cut costs and save on efficiency, helping the Balkans to grow even faster. So next slide, please. Now you've listened a little bit about the Balkans, and we will get into it more. Let me introduce the panelists. As I stated, my name is Madeline Pryor. I am the English content specialist for 3D Natives, the largest international online media platform on 3D printing, which is available in English, Spanish, German, and French. I am the moderator today of this panel and especially the Q&A. Don't forget to ask your questions in the Q&A if you think of any. It makes it much more likely that I will see them. And now the panelists. So again, apologies for all mispronunciations. I am trying. So first is Letters Chavrousis, who received a scholarship to study mechanical engineering at the Aristotle University of Thessaloniki before continuing at RW2H Aachen at the School of Engineering for Production Finance. He has already acquired a wide experience in automotive and 2D printing industries, as he has worked for Audi, Daimler-Benz IG, Zycon International in various positions. Since 2016, he has been at Lino SA and is actively involved in AM projects. Next, we have Maria Yo, who studied geology at also studied geology at the Aristotle University of Thessaloniki. She also obtained an MSc in petroleum engineering at Heriot-Watt University of Edinburgh. From 2014, she started studying and acquiring her first experiences in 3D printing and designing, specializing in industrial and jewelry design, and worked as a CAD designer. They both come from Lino 3D Lab, which is a 3D printing lab in Greece, which seeks and adopts all AM edge technologies. And they have quite a few interesting case studies to show you later. Next, Carlo Cavallini holds a BSc and MSc in mechanical engineering from the University of Florence and PhD in industrial products and process innovation from Uni Marconi, Rome. After 3 years working in the Ferrari F1 team, he was identified as a technical leader for the brand new metallic AM department in Ferrari, where he worked with laser powder bed fusion and multi-laser machines. He has also worked at the premium Ferrari F1 team engineering partner and is currently at Desktop Metal. Giuseppe Cilia is the next one, who also has a mechanical engineering degree as well as design experience in medical equipment sector and previously worked at Sarin Biomedica. He worked to expand ALM applied to manufacturing and RP, and before becoming a regional sales manager at Desktop Metal. Desktop Metal, for those who don't know, is a leading international 3D printing manufacturer using especially innovative metal technologies, so that's not exclusive, such as binder jetting, and they are seeking to make 3D printing accessible to all. So a lot of interesting people today, and welcome everyone. So we can now get started.
And thank you for the introduction. I'm Lefteris Chavousis from Lino, and it's my honor to start the webinar showing some cases in our Balkan areas. As you already explained, by 2018, the share of manufacturing value added, especially in the Western Balkan countries, was on average only 12% of the GDP. Therefore, there was much lower than many European countries, particularly the new member states in EU. We understand that a lot of conventional manufacturing technologies are in Balkans, such as laser welding, machining, injection molding, metal or sheet forming, that they dominated the market, which is most cost-driven and is addressed as an export to the other European countries. The reason that the additive manufacturing is going to be a change in the Balkan countries that will offer alternatives to conventional technologies, like everywhere in the world, is the fact that this is an additive and not a conventional method manufacturing. So to create the final part, you don't really use a bigger part and make waste out of this, but you have as much as less waste as you can to create the final part. There are many pros that you can use for additive manufacturing, like shorter production time or total reduced material waste compared to traditional manufacturing. But it's also much cheaper to make prototypes compared to the expensive prototypes making with traditional manufacturing, but also the labor cost and the resources that you have to invest for that. So in general, additive manufacturing is a technology that came not only to produce prototypes, but also for short or medium run production. Now, Lino 3D is a lab, a 3D printing lab, which seeks and adapts all additive manufacturing edge technologies. With our expertised personnel and fully equipped facilities in Athens, we want to serve and support the Balkan manufacturers in their process and help them choose the right process additive manufacturing process, the right additive manufacturing materials, and of course, acquire the necessary skills to understand the stakes and the functioning of 3D printing technologies. We are currently based in Athens, but we're mastering a lot of different 3D printing technologies like nanoparticles jetting, SLAs, desktop metals binder jettings technologies. This is the panorama of our distribution partners for 3D printings that we offer different technologies, different materials for different applications. For example, for plastic materials, we use SLS, SLA, DLP, and FDM technologies, and not to forget, of course, the full color UV 3D printing technology. For metal materials, we use FFF, but also the newest binder jetting technology. However, we use also ceramic, where we use the nanoparticle jetting technology. Nevertheless, we also use gel dispensing printing technology with Massivit for extra large additive manufacturing scale. So the challenge that we have with all these technologies and materials is to create really any kind of solution for any case that can appear for us in the Balkan areas.
Giuseppe?
Hello. Thank you, Carlo. I'm very, very happy to be here. So good afternoon to everyone. And it's a pleasure again to be here. So thanks to 3D Native and to Lino 3D that give us a chance to explain our company and why our company, our desktop metal could be very, very interesting in this region in the Balkans. It's a very, very young company born in 2015 from people, let's say, coming from the MIT, probably the most important Institute of Technology worldwide in Boston, in Cambridge, close to Boston. And so some of the founders of the company, for example, invented the binder jetting, let's say, process and technologies early in 1988. Then the first step in 2018 with the first, let's say, studio machine shipped to the customer, and this was the beginning. Studio machine that Carlo will describe maybe later. It's a machine dedicated to low volume production in the product development, let's say, processes, and for, let's say, jigs and fixture. But in parallel, the company developed other technology, and in 2019, it was the first high volume throughput system installed at customer side, together with the presentation of the studio machine, a metal binder jetting solution, quite interesting, an end-to-end closed, let's say, system that will be described by Carlo maybe later. The last and important thing is related to the expansion of the company. Now the company is enough mature in order to invest into other technology, like in Envision Tech, for example, to cover the application for polymer, let's say, as well as the latest one is the acquisition of Forust, which opened the door to the wood, let's say, parts manufactured in additive manufacturing technology, which is quite interesting for, let's say, the environment sustainability. We can go ahead. And then just to say that we are present in more than 60 countries in the world. And this is a very, very short picture of our, let's say, current customers. The most important one, as you can see, the market verticals covered are very, very different from, let's say, fashion to automotive, passing through, let's say, medical device company, as well as educational institute. And so it's a technology that can, in our idea, fit very, very tremendously, let's say, the request typical of, let's say, a region like the Balkans. Balkans, which is, we can go ahead. This is the coverage. So as you can see, we are present in Europe and especially in the Balkans in this case. And then I said, why Balkans? Because Balkans for us is really a strategic area in which we are absolutely convinced that our technologies can make the difference, changing, let's say, the way the companies in this region are doing their let's say, business, and that can have an impact also in the economy, because as previously mentioned by Madeleine, we can go to the next slide, please. Okay, this is, let's say, the picture of let's say, the environment, but most important is the typical market, let's say, segment in this area, which are ranging from automotive to marine, let's say, application, passing through heavy and transformation industry, as well as a lot of plants working for the home appliances, let's say, sector. And the very, very interesting thing is that as mentioned by the, let's say, initial pool sent by Madeleine, this is a confirmation that in this region there is a very, very interesting awareness about the additive layer manufacturing, let's say, technology. And again, now with the Desktop Metal, we have the chance to propose the additive manufacturing not only for the rapid prototyping phase, which is the historical, let's say, application for additive manufacturing, but most important, and this is the reason why Desktop Metal is pushing in this region for this application, is for a production system. Production system means the capabilities to run mid-volume production till high-volume production, as Carlo will describe in the next minutes. So I will not spoil anything. I will not anticipate anything. I will let Carlo to explain, maybe close in a much more close way the technology and why this technology can help, let's say, the discrete manufacturer industry in the Balkans.
So next, please. Yeah. So our main goal in Desktop Metal is to leverage additive manufacturing technologies, and I will show you later what kind of technologies we are working with, to create a path to tooling-free manufacturing. Next slide, please. What does it mean, tooling-free manufacturing? You can see in this slide a lot of different standard and conventional manufacturing technologies explained in terms of complexity of the product, and also the volumes can be produced. Anyway, there is a common, let me say, background that is common to all the conventional technologies. You need tools. What does it mean, tools? You need to develop your tools, so long lead time. You can develop less design iteration. A lot of time you need to sacrifice the complexity and the performance and the feature of your design in front of manufacturing cost, technical limitation, and so on. So everything goes in the direction to increase the production cost and the manufacturing time to market on one side and lead time on the other side. Next, please. Next slide. Okay, perfect. So if you can see on this slide, there are a quick overview on the typical time to market, not lead time, time to market. So the time required to industrialize for the first time a new part number. If you compare standard manufacturing solution like machining, casting, MIM, and finally, the best one is the binder jetting, so our technology. If you can compare the standard time to market, you can see clearly what is the powerful of additive manufacturing and especially binder jetting, because you can save a lot of time in your manufacturing time to market. So you can be able to increase the number of iterations to optimize your design and to increase to an optimal level the performances of your product. And at the same time, you can be as fast as possible in the end market, creating a competitive advantage against your standard competitor. Next, please. So actually, all these, let me say, goal related to the reduction of time to market and sometimes the manufacturing cost can be, let me say, achieved by the general world of additive manufacturing. Anyway, if you consider specifically what we could understand by metal additive manufacturing, the standard technologies for example, laser beam powder bed fusion, we can say that such a kind of technology is not really able to create serial manufacturing opportunities. Why? Because the productivity is still really low. At the same time, it's not able to create a lot of prototyping opportunities because the technology, I mean laser beam powder bed fusion for metals, is still really complex and is still really expensive. So what is the basic idea of desktop metal? Next slide, please. Is to create completely the scenario for metal additive manufacturing. To create metal additive manufacturing 2.0. So this means to cut dramatically the manufacturing cost using metal additive manufacturing on one side, and to create much more user-friendly technologies. Next, please. This means metal additive manufacturing 2.0 for desktop metal. Next. So, as you maybe are aware about, desktop metal are currently working on a couple of different and pretty similar, let me say, technologies with metal. The first one is bound metal deposition, that is based on the, let me say, standard background of fused filament fabrication. So it's a really user-friendly technology, is a office-friendly technology. You don't need actually too much technical, let me say, background if you compare to fused filament fabrication to be able to manage such a kind of technology. And also you are able to create pretty complex prototypes in really short time. On the other side, there is binder jetting. Binder jetting is a really full production technology based on powder bed solution, where you can spread a specific binder able to solidify powder and to create your green part that will go in a furnace to run the complete sintering cycle. So it's a different technology, but for different application. Bound metal for prototype, binder jet for serial production. Next slide, please. So you can see here the full offer from desktop metal different systems. From, as I said, the real office-friendly studio system through jump into small batch production through the shop system based on binder jet. Then you can move to real serial production with the production system P1 and the top end of our portfolio that is represented by production system. Next slide, please. So here, if you remember the map I showed a few slides before to you with the different technologies, you can find how our products are able to position on different segments in terms of production scale, starting from pure prototyping with the studio system, moving through, let me say, a medium volume production with the shop and the P1, and finally real serial production, thousands of parts each week with the production P50 model. Next, please. So in this slide, you can, let me say, understand what I mean by no tooling or tooling-free production. That is our end goal. You can produce all these different parts without no tooling and in the same job. So I would like to say not 100% complexity for free, because complexity for free is meaningless, but you can create really complex production with really different part numbers at the same time, creating a lot of iteration to optimize your production. Next slide, please. So really a quick jump into a couple of our main systems, starting from the Studio 2. Next slide. So this is a technology based on fused filament fabrication. So you start to extrude a filament to create your green part like a standard sintering process. So you can move through the sintering phase where you will weld all together the metal particle. And finally, you can remove all your parts really easily because we have patented a specific technology able to let the support to be removed much more easily than the standard laser beam powder bed fusion technology. As you can see from the video, is a question of seconds, not hour, like laser beam powder bed fusion. Go ahead. Next slide. Next slide. Can you move? Okay, perfect. Maybe too much. Okay, so I yet explain this one. I explain you a lot of advantages of our technology. So it's user friendly. The material quality is really good. Is compliance with the standard MIM specification. You can put this machine into your office, technical office, to iterate really quickly. Lot of prototypes to optimize your design. Next, please. Okay, again, a lot of different parts can be made by different materials. Really interesting. With fused bound metal deposition, you can use also copper. That is pretty interesting, considering electrification, electronic stuff, and so on. But a lot of different material, like also different grade of steels, case hardening steels, and stainless steel grades. Next slide, please. So here you can find some different example of the complexity you can achieve with such a kind of technology. As Madeleine said, this webinar will be recorded and will be available on YouTube. So I don't want to take too much of time explaining all the details, but the most important stuff is related to the saving in terms of lead time. So you can save really a lot of lead time from 30 to 80% of lead time. Next slide, please. Again, some case studies from different technologies that are working in close collaboration with Desktop Metal. Here you can see some tools and also some final components. Gears made by case hardening steel and also hydraulic manifolds. Next slide, please. And now we can jump into binder jet. So as I said, binder jet is a completely different technology. It's based on the deposition of a selective binder jet onto a powder bed made by metallic powder. And this can be leveraged a lot of different features. First of all, if you compare to laser beam powder bed fusion, here you have a full isotropic material. You have really higher true output because this is not a vectoral based technology, it's a raster based technologies. And you can use more cheaper material because you can use almost the same powder as MIM. So a lot of advantages if you compare to standard metallic powder bed fusion technologies. Next slide, please. So especially our specific machines are able to save times if you compare to the competitors in terms of binder jet, because we are able to integrate different kind of phases of the full process in the same phase. So is itself quicker than laser beam powder bed fusion technologies, I mean binder jet, but Desktop Metal binder jet is much more quicker because it's able to smartly integrate some different passages of the process in the same phase. Next slide, please. This is our shop system, so go ahead. Next. This is specifically developed for mid-volume production and for the shop system, shop floor production. 3 basic modules: the printer, the depowder, and the sintering furnace. I yet explain you how this system is working, so we can go to the next slide because a lot of stuff to be explained. Again, you can use this system to produce mixed volume. batch production or real full series production with the same machine in the same job. Next, please. These are the main features of the machine. So it's a really user-friendly machine. You can install almost in an office, but maybe better to put on the shop floor. But again, you can produce a lot of parts, lot of complexity at the same time. Next. This is a really interesting and mostly an exclusive solution provided by Desktop Metal. We are able to simulate the full production. So you are able to cut a lot prototyping time required to create the optimal industrialization for your part. So everything can be simulated in your computer. Next slide. This is the standard complexity, again, you can achieve with the shop system. So mainly we are working with steels, different grades, but in the future we will be able to integrate also nickel-based alloys and cobalt chrome in the really close future. Next slide. Some examples, so a clutch plate. Next slide. Bearing housing, all made by 74 pH. Next. And here is an hot air nozzle, again, 74 pH still. You can save really a lot of lead time. Next is the same, yeah, you can go. You can increase your production through output, cutting a lot lead time by Desktop Metal shop system, and optimize your design. Next. This is the really last one, 1 minute, and I will finalize. This will be the next step of productivity. So you will be able to produce really hundreds and thousands of parts each day. Next slide. With a system developed for real serial production. Next. So here you can see the main feature. This system will be available starting from next week. And this will be a completely automatic system. So almost no contact by operators. Next slide. And you will find 2 different systems, the production system P1 that is yet available on the market, and the real production system P50. One main important, and then we will close this presentation, one main important feature of P1 and P50 is related to the fact that they are able to work under inert atmosphere. So you will be able to manage reactive materials like aluminum, titanium, precious materials, and so on. Next. These are the main features of the machines. You will be able to read from our recorded webinar. The P50, next. And the P1, more related with research and development for serial production. Again, real inert atmosphere. Next one. And that's all. Sorry to be a little bit more late, but a lot of details to share really quickly. Thank you.
Thank you so much, Carlos, and thank you so much, everyone. And let's move on to some of Lino 3D's case studies, just to see the things practically. The first case study, and I can say one of the most valuable ones, is the customized face mask by First Wave 3D. First Wave 3D develops and produces a line of face masks called Personal Air, made for individuals, healthcare professionals, educators, and businesses. The face mask has a customized, an advanced filtration and customized filtration for protection for you and those around you to make you feel safer. The customer, First Wave 3D, had a series of demands and managed to find all of them in the Balkans and specifically in Lino 3D. You can see, we can summarize all of the demands here and listed here. So the first step was the rapid prototyping. So the rapid prototyping is a procedure that requires accuracy and fine surface finish for the first prototypes. Next step is the functional prototyping, a procedure which requires, besides the accuracy, the fine surface finish, it surely acquires biocompatible materials and, of course, snap fit assembly in order to be placed on the face. Next steps was the rapid manufacturing and the short runs production, which also procedures which require not only accuracy, fine surface finish, compatible materials, and compatible materials, we also must take into consideration the volume of the printing. So all of these demands were successfully responded with EnvisionTech's DLP technology. You can see here some of our examples. Here is the assembly of the mask, the snap fit of the mask, and here is a kind of insert made with plastic from EnvisionTech DLP technology. So the last demand from the customer after the successfully prototyping was to decide to move on to massive production. And it was then when desktop metal and binder jetting technology proved its value. We produced metal inserts, you can see some here, 2 examples here, with shop system from desktop metal, the machine that Carlos showed before. And we produced to move on to massive production with versioning. This was a very important step, responding successfully to accuracy, surface finish, and snap fit accuracy, and snap fit assembly with large volume production. And we managed to develop basic, standard, and advanced version of face masks. And just a note that the advanced version has also printed ceramic filters in it. Let's move to the next case study. So our next case study was in the field of education with CERT, the Center for Research and Technology Hellas in the Balkans, located in northern Greece. We took part in a program to promote and show to education sectors how additive manufacturing can be emerging as a key technology for design and manufacturing. Specifically, we created and developed parts which will demonstrate properties like ready parts assembly, complex geometries, and parts customization. You can see here some parts we printed. We have here the gecko lizard printed with studio system from desktop metal as a ready part, assembled by the printer. And you can also see here the head of the dinosaur printed with shop system by desktop metal, and you can also see all of the details of the complex geometry that the part has. So we printed all of this stuff in order to give the students the opportunity to learn and connect with new technologies, and of course new 3D technologies with metal, and through the actual fabrication of the parts to enable them to develop parts that can be could not be achievable with the traditional manufacturing methods. And our last case study it's in the marine sector. It is widely known that for centuries in the Balkans, the marine industry is widespread and traditional. And countries like Greece, of course, Croatia and Slovenia has it in a very high percentage. As we surely know, the marine engines of all kinds and sizes keep developing and keep developing through time and through the technology evolution. However, there are parts that are a lot, however, there are parts of a lot of engines and transmissional parts that are not produced anymore, and they are considered obsolete. And at that point, Lino 3D stood out in the Balkans one more time again. So the demand of the specific customer was, the first step of the demand was the reverse engineering of the customer's existing stock. You can see here some of the customer's existing parts. Next step was the customization of the parts through the CAD design procedure. And as a result of these two steps, it came the on-demand production of the virtual stock we created. And we can see here some of the parts we printed with desktop metal binder jetting technology, subsystem, and we met the customer's requirement fully with this kind of technology. And we responded successfully to accuracy, snap fit assembly to the final results. Thank you. That was all from me. And I don't know, I finished a little earlier, I don't know.
No, we're perfectly on time. Great. So, well, thank you very much, everyone. That was really interesting, especially the case studies, seeing how it's already being used in the Balkans. I think it's especially interesting how there is a case of something that's being used in the US by a US company, but being made in the Balkans. That's, well, it's really showing how it's revolutionizing the area, isn't it?
Yes.
So we will move to the Q&A now. During the Q&A, feel free to keep asking questions. You can also ask questions anonymously if you are shy, but I won't say your names anyway, so don't worry about it. So I'm actually just going to start with one that I noticed in the chat so I don't lose it before going to the Q&A section. Again, please do ask in the Q&A section. It's much more likely that I'll see it. So one attendee asks, can you give an idea of AM adoption for manufacturing versus prototyping? I think this is probably for desktop metal, maybe Giuseppe, but Lino, I think you probably have some interesting insights for Balkans as well.
Okay, so well, it's a good question, Madeleine, for sure. And so the two processes are completely different, and also the expectation and the requirements, let's say. I can how can I say, walk through the two different solutions that we have and that Carlo presented so far. So, for example, how can I say, Studio, which is a typical, let's say, solution for the product development for rapid prototyping, has some characteristic so that it can be considered really a desktop device. So it can be placed inside, let's say, the technical departments, and let's say there is no specific requirement for the usage of the system. So the ramp up is quite, let's say, fast and how can I say, also sure. It is the same more or less also for the production, but keep in mind that we are talking about two completely different systems, and also pay attention. Production system for the additive layer manufacturing for mid-volume production, at least, is something really completely new in the market, because again, compared with the traditional system, the level and the throughput of the system is completely different. Production means, let's say, for example, that the system needs to, with the system, we need to handle maybe the powder and stuff like that. We have several devices in order to handle the powder during the process. So it's, how can I say, a bit complex, but compensated by the final throughput, because at the end of the story, Carlo can be more than happy to drive you through some example, but we can say that the final cost of the part is completely different. So the implementation maybe requires a bit longer, but it's justified by the level of the throughput of the machine, and for the final, let's say, total cost of ownership for the final cost per part, which is completely different. So the implementation of the two systems, let's say, for rapid prototyping rather than for manufacturing, depends on the two different, let's say, requirements behind the system itself, related to the process that the system should, let's say, support. Is it clear?
Yeah, am I unmuted? Yeah, I think it's clear for me. Lino, did you have anything to add, or shall we move to the next question?
No, we can move on to the next.
Perfect. Well, okay, we have quite a few questions, so I'm going to get as many of them as possible. If I don't get to yours, do feel free to message one of the emails on the screen, this desktop and Lino, and you can get some more of the specific questions answered as well. So the next question, which again, I think is for Giuseppe and desktop, but I think that again, Lino might have some interesting insights if you want to add, feel free, is how are you thinking of expanding this technology in the Balkans? So I'm assuming that's talking about desktop metal and AM, but what do you think?
About how what we can do desktop metal in order to support the implementation in this region.
Yeah, yeah, exactly.
So the picture behind and the strategy behind is in present of each one of us. It's Mr. Lefteris and Lino 3D, because I try to explain. We have a specific program also with the present into the market in order to allow, in this case, Lino 3D, to be available for the market in order to, let's say, increase the awareness of our technology, and in order to offer, for example, some services about, let's say, the production of parts with both the system, studio, and shop. What does it mean, Madeleine? It means that in a very, very open way, customer that has the interest can, let's say, join Lino in order to see the two systems working and to perceive, let's say, the implementation requirements that both of them requires. I mean, strategy is increase the awareness of the system and which pass through the, let's say, part production. Part production is something very, very important because it's the proof that the technology can support, let's say, the companies in this with this technology. Lefteris, what do you think?
Yes, indeed, Giuseppe. During the COVID difficult period, we have accepted many STL files in order to produce metal parts that was not possible to produce in any other way. And we supported a customer in that way in the Balkans. So thanks to Desktop Metal, we have now 2 fully operated systems in our demo center, ready to offer demos, benchmarks, or short part productions just to prove the technology, the applications, and also the innovativeness that jet biting offers in that case.
It's an, again, Madeleine, it's also an economic evaluation, let's say. And so I don't want to sell anything, any machine, of course, but it's just to let's say, to check with the audience what can be the evaluation in this case. And for example, Lino 3D is working closely with our let's say, staff and with Carlo in this specific case in order, for example, to build together the evaluation about the cost of the parts depending on the type of production that each single customer may have. And this is, let's say, a kind of a effort that we put on the table in order to make it simple for the company in the Balkans to evaluate, let's say, the technology, generally speaking, because we're talking about, okay, binder jetting, metal binder jetting, which is something completely new in the market. Is not filament, is not laser sintering. We are talking really about a new leading edge technology which can really change the shape of the business in this region as well as in the other part of the world, of course. But again, it can be seen as a real advantage.
Great. No, I think that's a very thorough answer. Of course, if the person who asks any follow-ups, do feel free to email either Desktop or Lino. So there have been some upvoted questions, so I'm actually going to just ask those first. First, there's one specifically on Greece. So Maria and Defteris, you are up. They say, hello, very cool webinar, thank you. Thank you to everyone involved. Quick question, what does material availability look like in Greece? Can we expect to find the same type of polymers as we would in North America? We can also expand that to maybe metals, like what kind of metals do you, materials, sorry, do you regularly find in Greece?
So we can say that we have the same availability of materials in Greece, but of course there are some materials that they already have FDA certification from the States, and they need to transfer the certification as the CE certification here. The period of this certification is a little bit long, but it doesn't mean that we don't get the materials. We have most of the materials here, and just to note that we have also materials that they are not existing in the States. You can also think about this, the opposite one.
Yeah, no, that's true. It's really interesting, and the different certifications as well. Okay, thank you. Next question as well, specifically for desktop. Carlo, you haven't spoken much, so if you'd like, you can answer this question. Why is Desktop Metals so passionate about Southeast European markets? Or either of you, really?
Okay. Lefteris, would you like to answer, or do you prefer that I answer? Because for my side, honestly, the reason why is because, again, we have a great margin to introduce our technology, and what I said, I'm perceiving, because I worked in the Balkans also in the past, and I perceive, let's say, a great awareness and attitude for this technology. So the reason why we are excited, simply because we can do great things in the region, together with the industry specific of this region. Together, of course, again, with our, let's say, valued commercial partner, not commercial, technical and commercial partner like Lino 3D, because I'm quite sure that they are doing a very, very great job with our system in their, let's say, facility. So they are really investing quite a lot also in the technical aspect of the process, which is mandatory in order to be successful in front of the other, in front of the companies. On my side, from my side, and also I think Carlo agreed in the same way. So we are really we are optimistic about the region, and this is the reason why we are pushing and investing into the region for this.
The perspective for the region is quite high, since there is a lot of educated people from the local universities that in the past they were forced to go abroad and work there. And now with additive manufacturing, they have the chance to work locally also for exporting in other countries. Another reason is that it used to be a cost-driven area for the Europe. And now with additive manufacturing, they have the ability to have added value on the product and also on the design of this technology, and bring back a lot of jobs that are exported in the past in high industrial, traditional machining countries. So I'm also quite optimistic for the Balkans, and we're very much close to education with Horizon or other EU grants that helps the scientists and the different R&D institutes in Balkans to promote their jobs.
This is a very, very important thing, because I have to mention previously my previous answer, but I forgot to say this. So educational institutes are fundamental. So, and I totally agree.
Okay, no, thank you very much. That was a very comprehensive answer from both. I see quite a few questions on prices. I recommend you emailing directly, either Lino or DM, for those specific questions, since we don't have a lot of time left. If it's all right with you guys, maybe you could stay 5 minutes longer to answer 1 or 2 more questions. We're nearly over. Great, so we'll try and get a few. We won't get to all of them, but again, you have on the screen email addresses if you'd like to ask. and I will ask a few more questions. One question that I noted from an anonymous attendee was, is there a specific technology or a family of AM, I'm assuming, that stands out in the Balkans? I'll address that to you, Maria and Hafez, since it's the region.
Well, to be honest, the last 6 years that we are involved in 3D printing, we have studied a lot of different technologies with different materials, as we said, and we tested most of the edge technologies that were existing. I think that Balkans needs the flexibility to reply in any demand they have. It's not a dedicated technology that could cover the local needs like in Germany or in UK, where the market is huge. Here we have a lot of different and small jobs that we have to cover with short runs, quick response on the market. So additive manufacturing is fitting to that, independent if this is plastic and SLA technology or metal agent binding. However, I would like to point that the metal technology fits more in the Balkans area, where the machining and the injection molding are dominating the rate of the conventional machining industry.
Great, thank you. And then I have a question that I am very certain is for Carlo from Desktop, which is there a way that you are measuring the internal stresses inside the models? I'm assuming from the examples you gave.
Not directly on the physical model, of course. There are a lot of standard different technologies you can use, the strain technologies, for example. But with the Light Sinter software, the simulation software I show you during the webinar, we are able to simulate the density gradient inside the green part, and related with this, also the strain and the stress during the sintering process. So we are able to simulate actually the main critical data you need to optimize your industrialization for your binder jet part.
Very great. Okay, and then a last minute question, but it's just popped up and it's interesting. I don't really know who to address this one to. Maybe Desktop, I guess. So there's a question that says, it is a very exciting technology field for sure. How do you safeguard the world from dangerous applications that might arise?
What does it mean?
So I think the question is specifically asking, and I'm assuming it's specifically for people with the technology, if there's any way to ensure that dangerous applications, I think probably specifically 3D printed weapons or things like that, you can prevent that from being used. I mean, it's
so I can see the problem is split into different, let's say, aspects. One is dangerous application, probably related to the data software protection, which is one thing. So we are protected because all the communication are encrypted. So we are taking all, let's say, the possible prevention in order to avoid and to refuse any attack to the data, of course. But the other question is more, let's say, related to the, let's say, to the lawyers, to the moral of the people. So we can't prevent the usage of our machine, and no one in the field of this can do this. For example, translating the answer in other technology like casting metal parts, rather than, let's say, CNC machine, we have the same problem. For example, one can purchase a small mill, a small turn with, let's say, few buckets, a few euros, with, let's say, 1,000 euros, and they can produce almost everything. So it's, I don't know, it's up to Carlo now if we have some filter on the software application in order to prevent some shape, but very, very difficult. If I understood correctly the question, of course.
I was excited to participate in Defense Expo yesterday and the day before yesterday in Greece, where a lot of military visitors were there asking how 3D printing can affect the construction of a gun or of things that maybe terrorism or others may use. So the answer is as simple as that. We cannot, because anyone who can have this technology can, print based on the STL file, whatever he can. So actually, this is a way of construction. And if you want to construct something that could be dangerous as an application, you can. I suppose the most important is how to protect the STL files that having this information from printing and not the production itself.
Mhm.
Okay, well, thank you. I think that's a very comprehensive answer. Sorry, we still have questions, but that's 5 minutes, so I think it's time to say goodbye. I sound like a broken record, but for anyone who didn't have your questions answered, feel free to message either Lino or DM and ask the questions specifically. And well, it's the way to get it answered, isn't it? So I will then say thank you again, everyone, for attending the webinar and for the very interesting questions at the end. Again, it will be recorded. If you want to see it again, or if you want to share it, or someone you know didn't get a chance to watch it, and will be put on 3D Native's YouTube channel, so check it out there. And well, I'll just say thank you as well to the panelists for your time. It was great to have your expertise on this matter. It was a very interesting webinar, and thank you. And well, I'll let the panelists say goodbye as well.
Thank you so much.
Goodbye.
It's been a pleasure.
It's been a pleasure, yes.
Bye-bye.
Well, I will end the webinar then. So have a great evening, day. I have no idea what time zones you all are in because it's virtual. And I hope to see you at 3D Native's next webinar. Bye.
Bye-bye.